Hi, my name is Talia. I'm a staff member at Discovery, and I'm going to help you do your homework today.
Today, we're doing what is probably the worst problem in the entire class. And a lot of people struggle with this problem, a lot of people ask about it in office hours, but I'm gonna make a video for it. And it's gonna be mediocre because we're doing the spinning wheel problem, and I'm gonna show you what I call the broke way to solve it, because there's a way to do it with math, but honestly, it's really hard and I'm not even super sure how to do that. So I'm gonna show you the way I tell people how to do this problem. Hopefully it'll help you too. So I'm sure all of you guys are familiar with this problem. You spin two wheels, in this case they're labeled 1 through 7, and you want to be able to find the probability that, for example, both land on a multiple of 3, or the first value is strictly less than 5. And so this problem takes many forms, there's a lot of variations, and one of the main things that's really important to remember in this problem is just that the wording is so crucial, because it can get confusing whether it's and or, whether it's strictly less than or less than or equal to, how many numbers there are. There's a lot of different variants, and all you have to do is read through it slowly, make sure you know your conditions, make sure you know your numbers, and it'll be fine. So in this case, like I said, 1 through 7, and both of them are going to land on a multiple of 3 for the first condition, and the second condition is that the first value is strictly less than 5. And so here I've drawn a table, and this table is really powerful because, as you can see, the columns represent wheel 1 and the rows represent wheel 2. And this table, this box with a bunch of smaller boxes, represents every possible outcome of spinning these two wheels. No matter what, when you spin two wheels, your outcome will be in here. You can get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 2 and a 1, a 2 and a 2, a 2 and a 3, so on. I'm not going to say all 49 options because that would take too long, but that's what we have here. And all you have to do is get 2 different colors, and if you're not able to have pens, you can do something like make squiggly lines or make dash
X's and
lines.
O's.
X's and O's. You can do X's and O's. Great suggestion, cameraman. Anyway, and you want to mark all the situations that match your 2 conditions. And this is the same approach that you'll take whether or not it's and or. The only difference is how you analyze the different boxes at the end. And I'll show you how to do that also. So you can switch this approach no matter what the problem actually is asking you. So yeah, to start out, let's do the first condition, that both wheels land on a multiple of 3. And in this box, we see the only 2 multiples of 3 in the numbers 1 through 7 are 3 and 6. So for both wheels to land on a multiple of 3, we only have 3 and 3, 3 and 6, 6 and 3, and 6 and 6. So that's 4 cases that satisfy the first condition. Now we're going to mark all cases that that satisfy the second condition. And that's the first value is strictly less than 5. So when you're doing these problems, it's important to keep track of which one is wheel 1 and which one is wheel 2. In this case, I said that the columns are wheel 1, so that's the first value, strictly less than 5. So that doesn't include 5, that means only 4, 3, 2, 1, because strictly less discounts the equality, if that makes sense. So you want to be able to mark every single 4 or less. And sometimes you can do this with X's. Usually I just like to draw a big box around it to save time. So I'm going to do that and just say, alright, all of these boxes count. And that's it. You've marked every single case that you're asked to analyze. And the only thing that's left is to find the actual probability. So we know that there's 49 total boxes. So your denominator is going to be 49. Because, this is all of the possibilities, and then you want to filter it down by your number of successes. And the key word here is or, because you don't want to double count. A lot of people make the mistake of counting everything and not subtracting these 2 cases that you're going to count twice. Does that make sense? Because you can count 4 out of 49 cases here, and then you can count 28 out of 49 cases here, but the right answer is not, this is not right. If you remember from earlier in class, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. And that's because if you do this, you will double count these two boxes. So instead, all you do is count every unique box that is marked. So instead of, does that make sense? Like instead of counting this box twice, it's just marked, period, so you count it one time. And what you'll get from that is, all right, we have 28 here, plus the 2 that are left outside the OR. And you will get 30 out of 49. And that's your answer. And it can be a little tedious to draw out this whole square, but it's foolproof. It's not subject to math errors or comprehension errors that often come with trying to do this mathematically and with formulas. So that's why I tell people to do it this way. To go back to what I was saying earlier, if this said and instead, you would only count the boxes that are marked twice, because this only has one condition, although these only have one condition, but these have both. So if it said and, write down, it's 2 out of 49. I hope that makes sense. I don't want to go over that in too much detail because I feel like it's kind of redundant, but that's the wheel problem. I hope this helps.